Good morning class and welcome to another lecture in Sustainable Energy Technology course. In the last two classes, we looked at the various requirements of energy demand that is there for different locations and different places during different months and different times of day. And we saw how a classical traditional grid has different classes of power generation systems that cater to these varying demands. We saw the classification of base load power plants, cycling or intermediate load power plants, and peak load power plants. We also discussed how renewable energy generation systems suffer from some key disadvantages compared to traditional energy systems in terms of diurnal and seasonal variability of supply as well as intermittency of supply that makes it difficult to integrate them into the grid on a large scale. And we said that there are certain technologies that can help mitigate these concerns, and one of the major types of this technology that can do that is energy storage technology. So in the next few classes, starting from today, we will discuss the various types of energy storage systems that exist in the world and how they can be applied in the context of renewable energy production and distribution. So today we start our discussion on energy storage systems. So first, we will look at applications of energy storage. The first place where energy storage can be applied is utility level storage. Utility level storage. So these are large energy storage facilities that are used in conjunction with renewable energy generation in order to overcome supply intermittency and variability concerns. Okay. The second type where energy storage systems can be used. So the previous case we have discussed already that these are basically placed at the distribution end of the system, at the supply end of the system before entering the grid, and placed together with renewable energy generation systems so that they can store excess power during times of high supply and supply this stored power or electricity when the demand exceeds the supply, so that the renewable energy supply intermittency and variability concerns can be addressed. The next type of energy storage system is energy storage to maintain power quality. So, this requires lower capacity and faster responding energy storage systems. These ensure uninterrupted power supply at required amperage and voltage to the user. They help buffer short-term and short time scale fluctuations in renewable energy production. Example, temporary drops in wind velocity, short-term cloudiness, etc. So, the main difference between the previous case where we are looking at utility level storage is these are large capacity energy storage systems that are looking to buffer large scale variability in storage and supply. So, for example, if you are looking at a solar power farm, then you will require a large scale energy storage system to cover for the night times when there is no actual supply coming from the solar generation plant. So, there we will store the excess electricity generated during the daytime in these storage systems and then push this electricity to the grid at night times. Okay. Similarly, we can think of long periods of calmness that we can expect, say, based on meteorological predictions on wind energy systems, and so store large amounts of electricity during the windy times and then push this electricity during relatively periods of relative calm. On the other hand, the energy storage to maintain power quality is basically used to make the delivery uniform in terms of voltage and amperage. If the delivery is not uniform, you will see voltage fluctuations and wattage fluctuations in your electricity supply that can harm appliances if it is happening frequently, as we see often in many places in India even today. So the task of these fast response energy storage systems is to quickly turn on and turn off, absorb some excess power during periods when the supply exceeds demand, say for a period of few minutes, and push this power quickly when there is a sudden demand supply mismatch due to, say, a sudden drop in the power generation over a space of a few minutes due to decrease in wind velocity, or that can affect a wind farm, or a temporary cloudiness in the sky that can impact the solar power generation. Okay, so these are fast responding energy storage systems that are helping to keep good quality power to the grid, so that the grid can maintain uniform voltage and uniform amperage at the user end. Okay, so while the utility scale storage is large capacity, relatively slow response storage systems, these are low capacity, high responding storage systems, and hence these two require somewhat different types of technology in them. Okay, so we will discuss the various types of technology later, but we can see already that there are different types of energy storage that are required for a renewable energy grid to work properly. The third type is distributed grid energy storage. So these are found in remote locations or locations away from the primary grid at the consumer end. The consumers use these storage systems to satisfy their energy demand. So, for example, an energy storage system associated with a localized solar or wind farm facility in a rural area unconnected with the national grid. Okay. So there are many places in the country and in many parts of the world which are at remote locations, rural locations, mountainous locations, villages in depths of forests, etc., where it's too difficult to have a centralized grid serving electricity to them. So there we can install local wind farms, local solar power plants, local biogas based electricity generation facilities, and we can have a standalone energy storage system associated with this local power generation systems in order to store excess energy and give it at times when the renewable energy supply is lower than the local demand. So these are basically distributed grid energy storage systems that are helping to supply high quality power over the entire period of the day through renewable energy technologies in remote locations which are unconnected from the centralized grid. Another place where energy storage is becoming more and more important is energy storage for electrical automotives. So these are basically batteries for electric and hybrid vehicles. So this is becoming a very emerging technology where instead of the traditional IC engine systems, we are using portable large-scale battery packs to fuel our two-wheelers, four-wheelers, and even buses nowadays. Okay, so here these kinds of automotive systems require a battery pack with sufficient power to run these vehicles on the road for many hundreds of miles, and it requires recharge after the battery. It can be recharged from the grid quickly and easily. Okay, so these have unique needs to cater to automotive technology usage demands. So one of the unique needs is they have to be fast charging, because a person may not have the time to charge them overnight at home. If you are going on a road and your battery gets discharged, it needs to be charged relatively fast enough so that you do not have to wait hours and hours to get it charged on the road. Okay. Similarly, it has to respond quickly to changes in speeds. So acceleration and deceleration, start-stop operation of an automotive system. It has to be mobile and relatively lightweight so that it can be fit into the car, and the car itself does not become so heavy that it takes more and more power to run it over a period of time. So those kinds, it has to have a very good cooling and thermal management system so that the battery does not overheat due to continuous operation. Okay. So those kinds of needs have created a very promising and challenging EV vehicle battery technology as the EV vehicles become more and more common throughout the world as well as in India. Okay. Finally, we have non-energy uses. These are like small, portable energy storage units for electronics and personal devices like batteries for laptops, mobile phones, etc. Okay. So this is a very separate piece of technology, and we will not discuss these to that extent, but we have a ubiquitous use of batteries, especially lithium-ion batteries, for the portable electrical devices like laptops, mobile phones, cameras, etc., that have become very common in the last few decades. And the revolution in energy storage technology is, of course, initially has been driven by this the need for electronics to have high energy density, lightweight energy storage options. And the technological breakthroughs there have been able to be repurposed for this for the renewable energy grid storage systems. So here we see very fortunate, in my opinion, convergence of the needs of two different industries: the electronics and the semiconductor industry and the energy industry. So for example, we have discussed this a little bit previously as well. The solar cell technology relies on semiconductor devices, and the growth in the semiconductor device industry for computers, electronics, etc., has made it possible to have solar cells economical, and has pushed the development of more and more better quality, more efficient solar cell manufacturing and maintenance systems. So solar energy utilization has been boosted by a technology that has been originally developed for electronics and semiconductor industry. Similarly, the battery technology has also been a beneficiary of the electronics and semiconductor industry, because they have also needs of portable, lightweight, long-lasting, easy-to-charge batteries that are small and compact, and that development has helped in the development of good quality energy storage systems for the renewable energy grid also happens to need. So these are the applications. We will also look at some of the parameters that are necessary for the energy storage technologies, but we will look at that in the next class. So thank you for listening, and hope to see you in the next video lecture as well. So this is all for now, and have a very good day.